Okay, take three. Turns out my iPad was out of memory and it kept on basically stopping the recording and giving me a very short version at the end. So instead of the last 5 minutes of the show, I guess I gotta do it a third time around. And I do have some writing that was done on the take two last time. This is going to be the lecture for Tuesday, October 13, Chapter 8.2, Voting and Social Change, Voting Systems, How Do We Choose a Winner? That'll be the first part of 8.2. The writing has already been done on it from before, but that's just the way it is. This is my third run through now on this lecture, so I'm getting a little tired of it. But let's get through it here. Got a lot to do today. So, voting system is the first definition we have here. And they do say in the book that if you have a majority, there's nothing to worry about. If you have three or more candidates and there's no majority, that's where the fun begins. And they say there's no equally fair way to do it. That's the way they start off the book, which is not exactly the same as the slideshow. And I found that, of course, the second edition is preferable to the third. They're almost the same, and there's more color and a little bit easier to read on the second edition. You can find your third edition slideshow, I believe, inside the WebAssign if you look hard enough. Anyway, there's a set of rules under which a winner is determined in an election. That's pretty basic. Plurality voting kind of emphasizes the fact that perhaps you don't have a majority on the way. And so this says the candidate that receives more votes than any other candidate is the winner, majority or not. And plurality kind of assumes that maybe it isn't a majority, but it would cover a majority as well, I suppose. They have an extreme example here, trying not to look at the other writing that I did before. If four candidates run and there are 100 votes, what's the smallest number that you could have and win? If the four candidates have an equal number of votes, they would have 25 votes each, a four-way tie. Very unlikely, but not impossible. So then if a candidate got one more vote than that and added 1 to the 25 and got to 26, they would be the winner with only 26 votes. The example I'd already listed here was 25 and 25 for the second place winners, second place people, and then the last place person only has 24. Almost a four-way tie. An example here that they also listed in the book was having 5 candidates. If that were the case and you had equal shares for everybody, 100 divided by 5 would be 20 apiece, a 5-way tie. If somebody got one extra vote, such as in this example here, the 21 would be the winner. And then here's the possibilities. You could have a 3-way second place tie, and then last place, 5th place, would be the person with only 19 votes. Also very unlikely, but they're showing you how pluralities can really be quite a bit less than a majority in some cases. Okay, here's a example here along with a definition. A spoiler is called a candidate who has no realistic chance of winning, but whose presence in the election affects the outcome. Okay, yeah, a lot of third and fourth party candidates are considered spoilers a lot of the time. And in some cases, they actually do have a real chance of winning. I wish it was that way more often, but it's not right now. In the 1996 presidential race, the 3 major candidates were Bill Clinton, the Democrat, Robert Dole, the Republican, and H. Ross Perot, the Reform Party candidate. He got a lot of popular votes, but I don't believe he got any electoral votes. But he did get quite a bit, something like 15% of the electorate. I have to look that up. Anyway, for Florida only, this is how the votes went. Clinton won, Dole was in second, Perot got 500,000 votes, but still was in third, and then the others got some votes too. And they'll say later that Florida was actually a plurality state, so they got all 25 votes. Well, anyway, question number 1. What percentage of all votes cast in Florida were for Clinton? And did anybody get a majority? Well, let's skip ahead to the next slide and give you the answer to that. We simply, on our calculator, put down Clinton's votes, 2.5 million, and we divide by the total, 5.3 million, and we get a total of 48%, approximately. And it is not a majority. Not a majority. Clinton won more votes. No candidate received a majority, because if he's the leader and he doesn't have a majority, how could the others suddenly have a majority? It doesn't make any sense. And anyway, let's go back here. And they do say Florida determines the winner of a presidential election by plurality. So Clinton was declared the winner of all 25 of Florida's electoral votes. And by the way, only Maine and Nebraska split their votes proportionately, but neither one has a lot of votes. So they don't get a lot of press, so to speak, media coverage, because they only have 4 or 5 votes to split up, and that is not really earth-shattering. Imagine if California or Texas were to split up their votes. That would make a big difference. It wouldn't be winner take all, such as like 55 votes California, winner take all. They might be split like 28 versus 27 in a close election, that kind of thing. That could make a big swing on the overall total, which is only around 500 votes. Well, anyway, let's get back to the topic here. Let's suppose that the vote was conducted with only the top 3 candidates and all their supporters continued to vote for them. Would it be possible for any of the 3 to get a majority if all the votes cast for others were voted or awarded to Clinton? So let's say that other voters went to Clinton. That's number 2 on this list of questions. And so here's number 2. Suppose that all of the 28,000 some go to Clinton, and he would have received a little bit more than before. And before he had that many, and now he's up to this many, 2,575,000 votes. But as they say, to get to the halfway mark of the total number of votes was 2.65 million. Not quite there. He still did not have a majority. If this were to occur, this is hypothetical. We have a couple of hypotheticals coming up. And of course, if he didn't get a majority, even with the others tossed in, then the others could not have done the same either because they had less than Clinton. Let's go back and look at number 3. This is speculation, but it's certainly done anytime a third-party candidate is becoming a spoiler or close to a spoiler. They said that by far most Perot voters would have voted for Dole, the Republican, if Perot was not in the race. In other words, he stole more votes from the Republican than he did from the Democrat. And they're going to make a supposition. This is a coulda, woulda, shoulda, what-if situation. They're going to say that 83% of the votes for Perot would have voted for Dole and only 17% for Clinton. Then, in this what-if situation, how many votes would Clinton have had and how many would Dole have had? Who would have won the election? And would you call Perot a spoiler in this case? Well, let's find out. So we look at Perot's votes, nearly 500,000. I circled it right here, 483,000. If we take 83% of that, that's a big bonus for Dole. Dole would have gotten an extra 400,000 votes, and you add that to his total, and suddenly he's up to 2.6 million votes. That's quite a bit more than what he used to have. And you could refer back to the table or your book to see what he had before. It was about 2.2 million. Now, Clinton still gets a little bit of a bonus, 17% of the nearly 500,000 votes. He gets an extra 82,000, so it isn't like he gets nothing out of this. But his total now is less. It's 2,629,000 versus 2,646,000. So there is a subtle difference. And now Dole would have won with a margin of only 17,000. This is a big what if, of course. And if this were indeed true, then Perot would have been what they call a spoiler. And nobody could possibly know that 83% of the what if votes would go here and 17% would go there. And certainly sometimes third-party candidates are splitting the votes pretty much equally. So it turns out that it's really no big advantage to one side or the other. But this is just an interesting concept. Perot is considered to be more of a Republican in nature than a Democrat, so it seems like he stole more Republican votes. But same thing you could say for the year 2000 and several other situations where they steal primarily from one area or the other, so to speak. Stealing is probably the wrong word. I shouldn't be using that word. We have these different voting systems, and the ranked voting system has been used in several cities. The book points out Minneapolis, San Francisco, Oakland have used it in order to avoid runoff elections. Because if you already ask people for their ranked ballot, then there's virtually no need, virtually impossible to have a runoff vote. And of course, always the first round, you look at simply who they wanted to win. The first choice could be all that's needed. Because if you have enough to get a majority in the first preference number 1, and that gets a majority to say candidate A is the winner, period. But when there's no majority, that's where it gets interesting. And then the ranks start falling into place. And then you have to look at third place ranking, fourth place ranking, and all that does start to make a difference. I suppose if you truly didn't really have a second place choice, you could just leave that part blank. But the vast number of people would go ahead and put the rankings in, and so that would definitely get rid of the need for a runoff election, which with cities strapped for cash, they perhaps don't want to do that, or if they just want to get the election results out without waiting another month, then maybe that would be a smart way to go. It's always nice to get election returns in a timely way. So we'll see what happens this year. Nobody knows what will happen in the near future here. But anyway, we have systems in which voters express their ranked preferences, so they will put down a ranked ballot, used to avoid sometimes several rounds of voting. There's been more than one runoff in the past, and the voter lists his or her candidate preferences. Now, why this is dimming, I don't know. Two examples follow. This is the easy one. If no election receives a majority, there's a new election with only the two highest vote getters. This is what they're trying to avoid. So with cities that have lots of money and don't mind having a runoff, this is what's typical. But since we're trying to avoid this, trying to write the word typical there, this is the thing we're trying to get to, the elimination runoff system. Now, if somebody gets a majority, we're done. But if nobody gets a majority, then the way they're going to do is they're going to get rid of the lowest vote getter, kind of like you're voted off the island, or you've got to dance another day, or whatever they use for that other show. So a vote is taken again amongst those who are left. But they don't have to do a vote. They can just kind of look at the stuff. Well, anyway, let's take a look at some of the examples coming up here. And I've already kind of marked it up, unfortunately. I'm unable to erase the prior attempt here. Consider the following ranked ballot outcome for 10 voters choosing amongst 3 candidates. Okay, we have 4 voters in one voting block, all voting the same, and then another 4, and then another couple at the end. And they voted this way, Alfred, Betty, Gabby, and they did rank their top 3 choices. Apparently there are only 3 choices available. And so determine the winner under the elimination runoff system. By the way, if you just look at the first choice, it is 4-4 tie from Alfred to Gabby, so there is no clear winner here. So we go to the next slide and see how that goes. No candidate has a first choice majority. It was a tie, but Betty had the least. Notice Betty only had 2 voters. So and she got 2 in the first choice, so it's 4-4 to 2, and she's gone at first. So we cross her name off the list, and we take a look at what's left. Gabby moves up to second place in the first group. In the second group, they stay the same, but in the third group, the third column, Gabby becomes first and Alfred becomes second. So this is now reflected down with a new revised table. Betty's eliminated. The table is now as follows. And now the first choice votes are 4 for Alfred. Okay, that was no change. But now look at what happened over here in the second and third groupings. Gabby has suddenly emerged. Well, not suddenly. In the first case, she was already the winner. But here, it's moved up to first. And so a total of 6 first place votes. And now Gabby has the majority and is the winner. How about that? So we just eliminate the third place person and then re-rank them and see who wins amongst the first and second. So it really is important to get all the third place votes you can, or second place votes versus third place votes. I'm sorry I marked this one up, but that's just the way it tends to go sometimes. And let's go back to slide number 8. The board account is a method of ranked balloting that assigns for each ballot 0 to the last place person, 1 point to the next highest, and then so on. Say 2, for example, 2 points for the first one. Top first place winner, I guess you could say. The board winner then is the candidate with the highest board account, so we add up the points. So these are points. So decide on food in this example. 5 friends marked ranked ballots by preference. I can't imagine too many friends doing this. Maybe some math majors do this, I don't know. But I've never done it. Anyway, they rank their favorites, and the first 3 people vote the same way. They all like pizza the best. Number 1, pizza. Number 2, tacos. Number 3, burgers. And going kind of backwards, burgers being last got no points, none. Tacos being second place did get 1 point each, but pizza, being their first place choice, got 2 points each. So you see the points there. They've listed the points here, not the positioning. But then the last 2 people vote the same, and they don't feel the same way about pizza. That came in third place, 0 points. And burgers, well, they gave that second place, 1 point each. And they gave tacos, their favorite, 2 points each. And we add up the totals. That's going to happen on the next slide. 2 plus 2 plus 2 plus 0 plus 0 in the first column for pizza is only 6 points, but look at tacos. 1 plus 1 plus 1 for all those second place votes, and then a couple of first place votes. That does add up to 7. Burgers is a distant third, though. So anyway, what they're going to say here, coming up here, is that tacos is the winner. And that's the way it is. So they refer to the fact that the first place votes do get this 2 points. And there were 3 first place votes for pizza, which looks impressive, but when you compare it to the tacos that cleaned up on the second place numbers and got some first place votes also, tacos is our choice overall. And burgers just didn't rank at all here, unfortunately. So the group should order tacos, true in spite of the fact that pizza did receive a majority. So this is very interesting. It leads to our understanding that no voting system is perfect with 3 or more candidates. It's just kind of a revolving situation. So it has to be clearly understood that you're doing this method, period. You can't just suddenly change methods in the middle of the stream. Not a good place. A lot of people follow college football. Your book has the 2016 Heisman Trophy Award votes, and here we have the 2013 Heisman Trophy Award votes, and they list the top 3 first, second, and third place votes. And we need to find the board accounts and the board of winners. Before we even get started, it looks like Jameis Winston was way ahead. Look at all those first place votes he got, way ahead of A.J. McCarron. So let's take a look, though, at the board accounts to see how that could go. And your book does have a closer election, by the way. You can take a look at that for 2016. Okay, so the first place votes get 2 points. Second place votes get 1 point, and of course the last place, third place, gets 0. So you kind of go from last place up to first, because it may be 3-2-1-0 in the next example. This is a 2-1-0 point allotment. So Jay Winston did quite well. 668 first place votes, 2 points apiece. And then 84 times 1, 33 times 0 gets him a total of 1,420 board points. And let's just take a look at A.J. McCarron. Only 79 first place votes, gets 2 points apiece. That's not that much. He did get most of the second place votes, but they're only 1 point each. So, you got 320 votes. That's quite a gap between the two people. Sad to say, I guess. I don't really have a favorite here. But anyway, we can see how the other people also went along and got less and less points. Johnny Manziel, got 30 first place votes. That's 60 there. He got 103 second place votes. That's 103 points, and then 0. So you add those all up, and then, of course, only 163. I guess on the Borda scale, he came in 5th, from what I can gather. So as I go to this next one, sorry I marked it up a lot. I really didn't know it wasn't recording. But considering the following ranked ballot outcome for 100 voters choosing from options A, B, C, and D, who wins under plurality voting? I have trouble with speaking that word. Only looking at the first choice, A got 28 votes, and B got 25 votes. C got 24 votes. And plurality only cares about the first choice votes, and nothing else matters. This is the traditional way. And majority puts an even more stipulation on it. But if it was just plurality voting and they didn't care about a majority, A is just the winner with 28 votes. It certainly is simple. This is something that everybody would get on the test because it's really, really simple. But then we have the other systems. The top 2 runoff system, and we'll see that on the next slide. It's going to get rid of the 2 bottom ones. Notice how A and B are the ones they keep. A has 28 votes, B has 25 votes, but C and D are tossed out. So let's see what happens on the next slide. It doesn't do that automatically. I have to do it by hand. And so what they've done is they've removed C and D. And you can see that by looking at the other slide. If you take off C and D, say for the first column, then A beats B. In the second column, B beats A, etc. So let's take a look at the summary. A beats B, B beats A in the second column. C and D are gone. They're eliminated. So we do them both together. They're both eliminated at the same time. This is a faster way to go. But then suddenly B shows up ahead of A most of the time and gets 72 votes. I've already added it up here. B is the winner now with 25 and then 24 and 23. 72 doesn't even look like a close call. A only had the 28 that originally they had. So suddenly B is the winner, not A. So let's go to the selection number 3. Who wins under the elimination runoff system? It's a matter of just getting these names straight, I guess. Let's continue and continue. And now what's going to happen here, this is probably the longest one because you have to eliminate them one at a time, kind of like, you know, a Survivor type show where each week you lose somebody. There's so many shows like that. So in this particular case, we already saw that D was the one that came in fourth. They only had 23 votes, and they're eliminated first. So D is gone, and you can go back and take a look at the table and see where D would go. But now we look at the relative order of the other three, and A, B, C in the first column, B, C, A in the second column, etc. But D is nowhere to be found. So now we look at the subtotal so far. It looks like so far C is kind of ahead there on the last two columns. So we've got 24 and 23 that give us 47. We don't really care about that right now. We're looking for who gets eliminated. And we already got rid of D. Now we're going to get rid of B. So B gets tossed out, and notice how I'd started to do that in my prior non-lecture. And so now our column is reduced to just A beating C. Second column is reduced to C beating A. And then another CA and another CA, something that looks kind of like deja vu, except now we have C suddenly grabbing the lead. C gets those last three columns, so a total of 72 votes, and A still only maintained the first column. So it's just not enough anymore. C is now the winner on this particular method. So on the Borda scale, the last one, we simply, and this is probably my favorite because you just put the points on. You don't have to do any eliminating. You just count up the points and see what happens. And so in this particular case, remember last place gets 0. The next from the last gets 1, and the next one gets 2. Just climb the ladder. Now we're getting up to 3 points for first choice. So that's what I mean by 3, 2, 1, 0 versus just the others being 2, 1, 0. So looking at these where nobody's eliminated, let's look at the first column. Well, actually, look at the candidates. So candidate A, they won the first one. They won the biggest one, too. They get 3 points for those 28, and that sounds like that's a pretty good combination. But they came in last all the other times, and that's going to hurt them. They get 0 for each of the last 3 groups. 0 times 25, 0 times 24, 0 times 23. All they got was the original 84 votes. That's all they got. So we have the fact that B comes along and does a little bit better. They got third place for 1 point on the 28. So they got 1 point times 28. And then they come in first on this second group, 25 votes. First place gets you 3 votes. That's a good one for B. And they get to, third place on the next group. And they get 1 point for that. And they get another third place finish, 1 point for that. When you add it all up, it's 150 votes. Not too bad, really. But then the others have come out ahead. You can already see the winner. Quickly, I'll look at C. C came in last the first time, 0 points. Came in second, which is the same as 2 points. That's coincidence. And then came in first on the third group, big whopping 3 points on the 24 people there. And then second place again on the 23, so 168 points. And D is the surprise winner here, perhaps, because they didn't come in last at all, which is good. Good not to be last in these type of things. And D gets 2 points for the big group, the 28. They get only 1 point for a third place finish with a group of 25. They get 2 points for the 24 group, and they get the whopping winner on the smallest group, but because they didn't really do badly anywhere, they got more points than anybody else, and D is the overall winner. I'm going to save the results of that problem that I've done before. This is my third time through on this lecture, so I'm going to cut it off just a little bit. I think we've hit our time anyway, so we'll work out a few book problems next time, probably on the live lecture. If it works out to be significantly easier usually for me to do it on the recorded lectures, I will save some of those for the next recorded lecture. But we do expect to be live on Thursday the 15th with the second part of section 8.2. So that's all I have for today, and we'll talk to you later. Have a nice day. Bye-bye.